Okay, let's go ahead and solve the rest of these and then we'll be done with this section. All right, so example I, we can't change these into the same base. That does not mean we're stuck. Instead, we're going to throw in a function that's going to allow us to pull this exponent down. Because if the variable wasn't in the exponent, then it'd be pretty easy to solve. Well, we only have one type of function that allows us to do that, and that's a logarithm. And you can use any logarithm you want with any base. Personally, I just kind of default to LNs, but you could use log base 2, log base 39, log base 10. You know, you can use whatever log you want. Just kind of depends on what you want to do. So actually, I'll show you a couple ways you can do this one. So if I just did the ln, because I do default to an ln, but sometimes I don't use it, and I'll show you why not in a moment. But let's just go ahead and use it. So put in the ln. That's going to allow you to pull your exponent down. Now you got to pull down the whole thing, not just parts of it. Like that. Then you can distribute the ln of 2 add the ln of 2 to the other side. And then now you can divide by the 3 and the ln of 2. Okay, so this is a perfectly acceptable answer, but you got to watch out, because if this is like multiple choice on an exam or a quiz, it might not give this as a solution, because it's going to check to see, you know, do you actually know your properties? So that plus sign means you can multiply these on the top, so that can be ln of 10 over, and then the 3, if you pull that up to be the exponent of the 2, that could be ln of 8. So it could be a little sneaky like that. Okay, so now I said there was another way you could do this problem. So with this one, I'm gonna, instead of using an ln, I'm gonna use a log of base 2, and I'll show you why. So I'm gonna do that in green. And I don't care which way you go. The book is more than likely going to do it like this, or with log base 10. If you choose different bases, it's going to kind of make your answers a little bit different, but they're still all equivalent. Okay, so I'm going to use log base 2 since that's a 2. And the reason I'm doing that is because now the base is matched, so that all, whoops, forgot the log over here. The bases all cancel out, and so the left side just turns into 3x minus 1 is equal to log base 2 of 5. So you can add the 1 over, divide everything by 3, and just for notation's sake, I'm going to move the 1 in front so it doesn't look like you're trying to add 5 and 1 together. So you get 1 plus log base 2 of 5 all over 3, which if you use the properties and if you start kind of changing these things into the same base, you could change this green expression into that one. So for free response, that's typically we're going to see these. Like I don't care which way you go to solve it. You just want to pick the way that's easiest for you to work with. So if you like the blue way, that's totally fine. If you like the green way, that's totally fine too. The book is going to do it like this. So if you want to stick with what the book's doing, that's perfectly acceptable. This is kind of the sneaky mathematician way to do it, but anyway. So example J, just to be consistent with the book, I'm going to solve it just like this. well, do I want to do that? Actually, no, I'm going to do it the green way, just so you guys have a variety from what was done in the notes. So they both have an exponent of x, so you can choose which one you want to eliminate. You can either eliminate the 2 or eliminate the 5. It's not going to matter which one it is. You just got to go for one. So I usually pick the one that has the worst looking exponent. That's the one I'm going to try to get rid of. So I'm going to go with log base 2 again. You could go with log base 5 if you wanted to get rid of the 5s. Either way you want to go. Your answer will look different, but it's still equivalent. Okay, so the left side is now just 3x minus 1. The right side, I'm stuck with this, but I can at least pull down the x. So now I can get my x's to the same side. So let's just move the log over to the left. The 1 will move over to the right, and then I'll factor an x out. And now you can divide by the stuff in the parentheses. So you get a totally different looking answer, but it's equivalent to what the book would say or what we got in the actual notes. So don't panic if you look at the note key and you're like, hey, he got a different answer. Well, that's because I solved it in a different way. So you can go both ways, either with this one or the one that we did in the notes. To me, it's not going to matter. Okay, let's go ahead and do these next 2 examples. So 5 to the 2x minus 6 times 5 to the x plus 8 is equal to 0. So this is really, it's exponential, but it's really quadratic in disguise. Because 5 to the 2x, that's the same thing as saying like 5 to the x squared. Because you're multiplying them, so you can kind of pull them apart. So there's your squared term. There it is, just with a b in front. And the constant, or the c. So that's going to factor nicely into 5 to the x minus 4 and 5 to the x minus 2. So 5 to the x is equal to 4, and 5 to the x is equal to 2. And again, I'm going to solve it like I did earlier. I'm not going to solve it like I did in the notes. So I'm going to use log base 5. So I can get rid of the 5s. So x is going to equal log base 5 of 4. And then for this one, same thing. I'll use the log base 5 again. So the left side is x, and the right side just stays as log base 5 of 2, which again is different than the answer we got in the notes. But remember, we can use those log properties and convert it or change the base. So that would be ln of 2 over ln of 5, which is what we got in the notes, and something similar with this. Whoops. All right, last one. So let's go ahead and combine the logarithms together. So I'm multiplying these two things, so I got to distribute the x. It's x squared plus 4. Remember, this is log base e, so change it to exponential. So x squared plus 4 is equal to the base, which is e, and then the square. So what kind of equation is that? Oops, that should be a 4x. So anyway, what kind of equation is that? that's quadratic, so you got to set it to 0. And then use the quadratic formula to solve it, because this is not going to factor. Okay, so the a value is 1, b is 4, and c, even though it's weird, is going to be a negative e squared. So there's your a, b, and c. So b squared would be 16 minus 4 times a times c. So that's going to be a plus 4e squared all over 2a, or just 2. So let's simplify that down. So when you simplify this, you got to start within the radical. So if you look in the radical, you could pull off a 4. Well, if you're pulling off a 4 like this, you can actually root the 4 and leave the 4 plus e squared inside, which is not going to reduce because you have that plus sign in between them that messes it up. Well, now that we've reduced the radical, now we can reduce the fraction, because we can take a 2 out from the negative 4, the outside 2, and the 2 in the denominator. So negative 2 plus or minus root 4 plus e squared. And you got to check your answers to make sure that you don't get a negative inside of your log. So if it was just negative 2 minus the root, that's a negative number overall, which I can't use here. So the negative is definitely out. So now it's just a question if you can keep the positive. So again, how do you know what kind of a number this is without using a calculator? Well, you kind of have to reason your way through it. So e is 2.7. So that's a little bit smaller than 3. So if I squared it, it's going to be somewhere around like 7 or 8. So let's just say 7 just to be safe. 7 plus 4 is 11. If I square root 11, that's higher than a negative 2. So this result here, that's positive. And I can stick it in for this x and this x, and it's still going to be fine. So I get to keep that solution. If I had to toss it, like if this didn't work, then I would say no solution. All right, that is it for equation solving. So try the homework, look at the worksheets if you want, and let me know if you have any questions.